for joining today. So as you probably saw from the little blurb, I wanted to have a fun discussion with y'all today about some research projects that I've got going on and promising research directions that I'd love to get your input on, or maybe if there are interested collaborators, I would welcome that. So I've got some slides that I'll show, but I will go through them quickly, and I'll just use it as a way of kind of getting us all up to speed with what's going on, and maybe as a prompt for deeper discussion. All right, so you should see my, oh my goodness, hold on. I just realized this has some sort of voice recording with the slideshow because I used it for to create the video for the GVU showcase. All right, I think that's turned off now. All right, good. I was hearing my own voice talking along with the slide. All right, so what I'm talking about today is something I've been calling cognitive AR, and I'd also be open to coming up with a better name for it. And this is collaborative work with a longtime colleague, friend, and collaborator of mine, Dr. Anne McLaughlin, who is a professor in human factor psychology at NC State. And that's strange. It's like having all kinds of odd. My slides is missing. Hold on. Okay. I thought I was all organized. Like, I think that there's something weird about this slide deck because I had it set up for creating this video. So let me quickly here on the fly add back in other material with me. So. What happens? Hold on. So the point of the slide that I was going to put in here is I kind of wanted to first discuss a little bit with y'all what I mean by augmented reality in this particular context, because that's a term that's used all the time in lots of different ways, especially by industry versus how it's used in research. And so usually when I say AR, what I mean is the Ranazuma definition, which is you are taking virtual content and you are registering it in 3D in the physical world, and a user can interactively view and experience that physical world. So by that definition, something like the virtual first down line in when you watch like live football isn't AR, because although it's registering virtual content in 3D, the viewer cannot independently control their view. Today, I don't quite mean that. I mean kind of a looser definition of augmenting the physical world with virtual information, but not necessarily that very precise registering something in 3D, although we might at times be doing that. Now, AR from its birth back like in the early 90s has often been applied to supporting task performance, especially in work. So maintenance and repair, assembly, like industrial applications where someone is trying to do some sort of psychomotor task. AR is a great fit for that. So you're placing the instructions, whether it's virtual animations of an arrow saying like turn this knob, or the picture on the left is of one of the first AR applications that was guiding workers as they created wire harnesses for Boeing. So it was, showing a virtual trace of where the wire should go, and then the person can follow along with the physical wire. So there's a lot of power in the idea of placing guidance into the physical world rather than having a separate, whether it's a binder of instructions or a mobile device with information, right? Being able to situate it in the real world is really powerful. So we know from thousands of research studies that you definitely can create effective AR like job aids. One of the terms I'm going to use today that you may not be familiar with is diminished reality. So this is the idea of, instead of placing virtual content in the world, you're removing things from the world. So typically it would mean removing real stuff from the world that's actually there. If you look up the research related to this term, it's often computer vision and computer graphics research, where they're trying to figure out technically how to do this. Like, so how can I remove the vase from the table? How can I remove the table from the room? But in what I'm talking about, we're also applying this to other modalities, specifically being able to mediate the audio of the environment as well. So a simple version of that would be doing some noise cancellation, right? So we already have products that do that. So what do I mean by cognitive AR? So it's a little different than, show me the, take the instructions on how to build the wire harness, right, and overlay those virtual instructions on the real world. In this cognitive AR research, we're looking at how can we still want to support workers in performing like complex cognitive and motor tasks, but our goal here is to focus their attention and to reduce distraction. So not to take task-specific training content and put it in the world, but rather use AR as a mediator between the person and the real world in various ways to help them be able to focus their attention on what they're doing. And so we're wanting to reduce cognitive load and reduce attentional demands from irrelevant stimuli in the environment. And that can mean enhancing certain signals from the environment that are important for the task and diminishing signals from the environment that aren't relevant. Now, there are easy, low-tech ways of doing this, right? I mean, I can put earmuffs on you. I can put goggles on you. But the problem with that is, one, it's not smart, right? So it would be just blocking out, in a general way, blocking out signals. But also, it would reduce your situational awareness. And so I'm going to present scenarios that we're exploring with this research where I want to not be distracted, but it is critical that I continue to be aware of what's happening in my environment. I don't want to literally put blinders on. And what we are very interested in exploring multimodal augmented reality here. So we're both wanting to mediate visual and auditory signals from the real world, and we're going to do that through visual, auditory, and tactile output from the AR system. So we've got we have a variety of projects going on in this space. The first one I'm going to talk about is where we're trying to improve the experience for students in learning environments. And as I talk about this, keep in mind that the techniques I'm describing could be used in the real world. So I am in a real lecture hall, or I am in a real factory floor doing something, or it could be over telepresence. So you all have probably had a lot of experiences over the past year where during your telepresence session, there was both signals coming through the channel that were distracting. We've all had that, right? There's the barking dog and the crying baby or something weird happening in the background. But you were also missing key signals. You can't quite see everything you need to see. What the person's saying is muffled. So one of the things I'd like to just talk about in our discussion today is how these concepts could be applied to telepresence, because I think that is very interesting as well. So we wanted to apply these techniques to learning, especially for students like neurodivergent students who may struggle to block out these distracting signals. We're in a totally different realm. We have work funded by NASA to look at how to support the crew of the space station and the Mars mission, specifically when they're trying to do tasks during emergencies and high stress scenarios, where they may be like assembling a ventilator to use on a fellow crew member while, there's a fire or, something, there's a bunch of things happening around them. How can we help someone focus attention during those high stress tasks? And I've also, I teach an computer audio course, and I have students doing independent research with me. And so I've also been really interested in how to use sonification specifically to enhance situational awareness for people while they're doing tasks, and not just sonification, but also using haptic display. So anyway, we've got a lot of things going on in this realm. And most recently, we have a new project funded by Cisco where we're going to be applying this cognitive AR concept to high-stress healthcare environments in general. So not just on the space station, right, but in situations on Earth. Okay, so yeah, this is kind of just reiterating what I said, that we're wanting to specifically, we want to help people focus their attention. And the first set of experiments that we've done are looking just at what if we diminish the signal. So we're not really looking at the enhancement in this set of experiments. So we have some preliminary research results that we can report. And the lead on this work is Mitchell McDonald, who is a graduate student working with Ann McLaughlin at NC State. And so they did an experiment. It didn't involve augmented reality. What they did was create these videos where it was a lecture hall. It had distracting elements, visual and auditory elements happening. So it's a first-person point of view video. You'll see some of it in a minute. But they had different experimental conditions. So the control was just the normal video. Then they had versions that reduced the visual distractions through kind of standard techniques of like blurring or blocking out things in the video that are like there's a lot of movement. And then the same with the audio. So when there's like someone's laptop is suddenly playing music, or there's like loud typing, in the control you hear those normally, and then in these experimental conditions they're reduced through like filtering. And so they did an experiment to see how these diminishment techniques affected people's learning and their situational awareness. And I'll say, I'm not a psychologist, and I don't want to mangle their great work, so I wasn't going to talk about it too much beyond just kind of explaining a little more that, our goal here is to reduce this extraneous load, like mental load, that would come from your brain trying to process this irrelevant information. And, we know from lots of research that that irrelevant information will deplete your cognitive and sensory processing systems, and adversely affect your task performance or your learning. So real quickly, to kind of tell you the outcomes of this study, there were benefits from reducing this extraneous auditory and visual information. And this effect was greater on students with ADHD. there was also a reduction in situational awareness for people in these diminished reality environments, which is what we want to avoid, right? So there's some promising results from this. And there's also, this is an initial study using regular video. So it's not quite like a normal environment where you're looking around and, so where you're in control of your own view and you're not taking notes and doing all the other things that you would normally be doing in a classroom. But this is a really interesting start. So, and I realize I want y'all to hear. Oh, I guess you could hear audio. Let me see what's happening here. I know what I wanted to do. I wanted to talk about the images here real quick. So these are just some stills from the video to give you a sense of what these techniques look like in this little video version. So we have the professor teaching, and then some actors purposely doing kind of distracting things, walking around, showing distracting things on their laptops, making a lot of noise. And like the image on the right is from one of the experimental conditions where those non-relevant portions of the visuals are blurred out. So I don't know if you all can hear this video or not. There shouldn't be any audio really in this, but here, sorry, I know I'm kind of all over the place. Let me turn this off. So what I'm going to show now, so what's the next step of this research? So we need to have an interactive mixed reality environment to study these things in more depth. What you're seeing is really rough. So this is a think tank, so I'm just sharing with y'all some rough views of the application that we're currently building. There's also challenges here because, instead of bringing people into a lab or a real classroom environment, we needed to find a way to do these studies completely virtually. So our participants will be in their own homes using their own phones with a Google Cardboard mount. So we're creating a VR environment, but where we can similarly manipulate, we can selectively process components of the visuals. So having people appear blurry, but the rest of the room doesn't, or be able to selectively filter the audio from different sound sources. And so what you're seeing here are virtual. So it was also a challenge to create this content because we couldn't all be in the same room to shoot the video during COVID. So it's a bunch of green screen videos that we're putting together. So again, it does look really rough, but using this VR environment lets us have a very controlled mixed reality environment to test. And those of you that have worked in AR know that doing this stuff for real is really hard. And so it's kind of nice to be able to do some initial studies just in VR where we don't have all of the tracking requirements that we would for AR. We don't have to try to overcome the limitations of the field of view of existing AR displays and things like that. So what you have here is all of these videos of people were individually shot on green screen, so it lets us control them in different ways. The other nice thing about masks being the norm now is that, so we were all the actors in this thing and we got to wear masks. It allowed me to play very different characters in this video because I just put on different hats and different masks, and I could be a different person. But so anyway, this is super rough, just a window into kind of what we're working on right now for the next stage of this experiment, this interactive environment. And then we're also doing the same idea for the NASA study. In this case, the VR environment is the space station, and whereas in the other environment, someone will be just passively sitting and listening and learning the material from the lecturer while they're being distracted. In the space station, they're going to be attempting to do this assembly task with a ventilator. So there's going to be a virtual ventilator that they're trying to assemble while there's all these distractions going on. And again, we can study how these different diminishment techniques hopefully improve their ability to do that task. One other thing I'll mention, so some of the other kind of related work, so as part of the TechSage RERC for the past 2 years, we've kind of been exploring similar ideas with AR, but helping both consumers and the people that may be helping them install or use smart home technology, helping both of those stakeholders be able to do that task more effectively. So, there's a lot of spatial components of working with smart tech. Like even something like, oh, I got an Amazon Echo for Christmas. You have to figure out, like, where am I putting this? If I put it there, will it be able to hear my voice when I'm in the kitchen? Or it was working and now it doesn't seem to be working. Why is that? Well, some of the reasons might be due to the physical space that you're in, like it's too far from the wireless access point, or you didn't plug it in, right? So we've been looking at how to use augmented reality to let people see the unseen during that task, and studying how that can help them do a better job at choosing the technology, installing it, debugging it, which is a huge barrier for a lot of people, and also just developing an appropriate mental model of how these ecosystems work. Okay, so don't worry, I'm almost kind of at the end of my slides. This now leads me to this new work that we're starting with Cisco. So there's got to be all of this fundamental work that's a collaboration between computing and HCI and cognitive psychology and human factors, because we need to understand fundamentally what is the value of diminishing and enhancing signals to support focusing attention. And the computer scientists need to there is this iterative thing of us developing techniques to do that diminishment and enhancement, but then understanding if that's really working, right, at a basic cognitive level. But what do we do with all that fundamental knowledge? And so what we're starting to pursue now is this idea of a cognitive AR toolkit that would allow someone to kind of create this personalized mediation configuration depending on what task they're doing, and depending on what's going on in the environment around them. So the idea is that you would have, work contexts where someone is having to assess a physical system or manipulate a physical system. It could be someone in the field, installing an antenna. It could be a home healthcare worker in the home. It could be, someone on the space station. But this is particularly valuable when you're having to understand and work with the world around you. And the key actions, the key types of mediation that you could do is you could diminish signals from the environment, you can enhance them, and then we're starting to explore this idea of remapping. So taking the signals from one modality, like perhaps it's something visual that's happening around me, and now mapping that to a sonification that I'm hearing. So these signals from the environment are, again, whatever's happening visually, the ambient sound. It could also be environmental things like the temperature, the air quality, and it could come from sensors. So it could be not natural signals, but things like, what is the Wi-Fi strength right here? What Bluetooth devices are in range? Things like that. Activity recognition of things happening around me. Right, so this is just me kind of listing what when we say diminishing, what could that mean, right? With visuals, that could mean blurring, desaturating with colors, applying some sort of rendering technique, so now it looks more like a sketch, right, than a real physical thing. If it's audio, it's reducing the volume, filtering out certain frequencies, modulating it in some way. Whereas if you want to enhance something, you might sharpen the visual image. You might increase the contrast of the colors. You might apply a highlight over something. With the audio, you might be boosting certain frequency bands. And like I said, the remapping would be maybe sonifying something that was visual, or taking a sound from the environment and now representing that in some way through like a tactile display, like in your smartwatch. So here's some example scenarios. Let's say you're a trainee worker in the field. You're trying to do this task, and there's a remote expert that's connected over telepresence. So this remote expert might want to diminish certain sounds, ambient audio that's coming over the telepresence channel. So that might be like low pass filtering of some of the audio. But doing that might now do too much diminishment. Maybe there's certain words, like the person's name, or certain parts from the machine that you would want to know for sure when they were spoken. And this can be really hard. I've actually tried to do some like site visit type telepresence activities over the past year. And, you know, the people that are there physically are talking to each other, and you're trying to hear what's going on. So imagine if you remapped. So maybe some of those keywords, when they are detected, there's some sort of visual indicator on the screen that those were being spoken, right? You could also do some enhancements. So perhaps the person on site is pointing at a location in the physical space, and it's in view, like the actual video view of the remote person, but it may be hard to know what is that person pointing at. So you could apply a visual highlight to that segment of the video. Now let's imagine someone who is in the field. Maybe they're trying to install some new IoT system, right, in the community. You could diminish the distraction of some of the foliage that's moving and bright, and it's obscuring things in the scene, and it's just keeping you from being able to really, maybe you're trying to lay out certain devices around a space that are going to need to communicate to each other, and you're trying to think through things like, you know, what's going to happen when the sun moves to a different position? What's going to happen in the spring when all the leaves come, right? And there's no need to be distracted by some of this visual information. So you could desaturate, you know, certain hues in the visuals that the person's seeing. But then conversely, maybe what they're trying to study is like, well, or figure out is like, where do I put this device and it'll still have a strong Wi-Fi signal? So as you're walking around the space, there could be a vibration on your smartwatch that's mapped to that Wi-Fi signal. Similarly, you might have sonification as you're approaching to give you a sense of how many devices you're in Bluetooth range of. You might hear a changing sonification, a Geiger counter type, like ticking, for example, that's letting you know how many devices you're in range of. All right, so to conclude, I know this is kind of a busy diagram, but this is showing you what we imagine this toolkit would ultimately be like, that there are all of these real-world inputs that would be coming in through cameras and microphones and other sensors, and then you have this understanding of the cognitive processes that are underlying whatever task the person's trying to do. Are they you want them to pay more attention? You want to be able to remember something? You want them to perceive something more clearly? They're trying to make a decision, right? And so there's a bunch of fundamental psychological knowledge that we have that informs that. And then we have these AR techniques that we can apply to those signals. So we got to figure out, what are we mapping these signals to, and what AR techniques are we applying to them? And then ultimately that's displayed to the user. This mediated experience is displayed to them via, you know, it could be a true AR HUD, right? Like a HoloLens, or it could be something more low tech than that. It could even be like a monocular, like Google Glass display with just a HUD, you know, earbuds for audio. And you could have lots of different kinds of tactile displays, again, like a smartwatch or a glove, or vibro-tactile displays in your clothing, things like that. Okay, so that is my quick, hopefully quick introduction to what we've been thinking about. And so anyway, I'd love to hear from y'all about what your thoughts are on this, and directions that we should be going, and everything. So what say you?
I like this idea of diminished reality. At some point, when we have like computer vision installed in our eyeballs, I can just delete people I don't want to pay attention to. Right?
Well, there is a Black Mirror episode where they do that. When someone is a criminal, they can go around in the world, but the other people are just like this white noise, like blurred out thing, and they can't communicate. You're basically
Yeah,
in this prison that you can't see or hear or interact with the other people.
it reminds me of that novel, City in a City by China
Yeah.
Millville, where like two societies live right on top of each other, but they just don't pay attention to each other and they learn how not to see each other, which is basically what Facebook is now anyway. But
Yeah. Well, yeah. So thanks for bringing up the horrifying dystopian outcomes that can come from this work, Clint.
you're welcome.
Like, let's help students that are struggling in the classroom, like, or create a horrific society of, of pariahs that aren't allowed to interact.
But
So,
I've been,
Go ahead, Russ.
sorry,
sorry, good point.
I was gonna
No,
say I've
no,
been
he
working
was
with
going to
you on
finish
some
the
of
thought.
this stuff, so I've known about it. And but when you described it this time, that's what I thought of.
So when you first started talking about that part of it, the first thing I thought of was I was like, what are some everyday examples? I was like, wait, here's some right here in my hand, right? I
Yep.
wear these all the time to eliminate UV and glare and distraction, right? This is exactly what we're talking about is tools that help us remove distraction
Hmm.
and be able to work. And I think modern cars, right? Modern car user interfaces have many of the cars I have driven, rental cars and what have you. I'm like, holy crap, they completely missed the point of safety devices because they have created all these distractions for me while I'm driving that I have to look at all this crap on the screens and push buttons instead of watching where I'm going. All right, and it's like, okay, it's time to be more reductionist here and take some of this stuff away. So this is cool, and I'm intrigued by it. But of course, the other you set me up with the sensor installation discussion as well, and one of the things I was thinking about when you're talking was specifically I have this challenge when we go install on a bridge, and that I need to know what it looks like at different weather events, right? So what does it look like here? What I'd really like to know, what does it look like here when it's flooding? Or if it is high tide, what does it look like at low tide? Because we need to put the sensor somewhere where there's not going to be some obstruction below it at low tide. And so, unless there's somebody with us that knows, that's been there or has taken a picture, we have to go back, right? Or we hope we get lucky. And so there is, I was imagining with, I really like this, the home installation, the home automation installation stuff, all these different aspects of how do we assist, give more information to that installer to understand the context that's, what this is, be aware of that this environment changes and it's not always going to be like this. And here's actually the range of things you're going to see while you're or that this device is going to experience over the next year. So you need to be thinking about that too, right? That's
Yeah,
cool
and
stuff.
you and I have talked about this a little bit before, and but now I'm kind of in the context of this toolkit. You can imagine these signals don't have to be live. So you can imagine if these signals have been recorded, whether it's video from a traffic cam of the water at different levels or sensor data from that bridge at different times or the sound of traffic at different times of day or, or the video of people walking on this sidewalk during, the Dogwood Festival versus, late on a Monday night. You can imagine all those signals now being able to be presented in different ways, even though they're not happening now live. Yeah, so that my little diagram, those signals don't all have to be the current live ones. They could be archived.
Yeah, and I think in some of the examples I've thought of, the historical is actually more valuable than the live, because I want to
Hmm.
know what it looks like at other times of year.
Hmm.
So, Mary Beth, I don't know if I missed this in your examples. I was thinking of the different types of. You guys hear me?
Hmm.
Okay, sorry. The moderator is muting you. Okay. We've had different types of VR environments where the goal is to understand the experience of someone with different types, with differing abilities. Um, And so if there would be a version of this that it's like, what is it like to, what is the typical experience of an 80-year-old wandering around this environment as opposed to, a quote regular able-bodied person. So this notion of enhancing and decreasing certain types of perceptual abilities as a way of the walking in the shoes type of
Hmm.
experience.
Yeah,
And
you
that
can
could
imagine.
even
Yeah, I'm sorry.
I
Go
would
ahead.
say you could even have a narrative, internal narrative like Three Angry Men, which kind of also conveys some of the perhaps emotional responses.
Hmm. Yeah, and that's something that Anne and I have talked about before. Like, so a use of this tool could be to, yeah, to purposely to mediate your experience in this very purposeful way to recreate the experience of people with different sorts of impairments.
Along those same lines, in terms of sort of serving more neurodivergent populations, the educational tech component of this, where it was being used with people with ADHD,
Hmm.
reminded me of a paper that I read a few months ago, where essentially EEG data was being used as a sort of biofeedback mechanism to sort of help people realize when their attention was being focused or not, and as a way to sort of scaffold that process. And I wonder if that might play any role with this.
Mm-hmm. Yeah, so yeah, that's an interesting thought. So you can imagine that an input to this system that's kind of helping turn the knob on these mappings and these techniques could be controlled by some sort of biometric data. So like if the person is starting to become stressed or anxious, maybe you like turn up the knob on like the diminishment to like make it less overwhelming. Um, yeah, so that's a cool idea.
Right,
It's
and
like
maybe
an
conversely,
auto.
right.
Gone. Mhm.
I said maybe, and maybe even conversely, like removing some of the diminishing as sort of scaffolding, like as they're getting better at maintaining focus, you can sort of expose them more and more to like the
Mhm.
total of reality.
Mhm. Yeah. Also, say if you have any students who are good Unity programmers that would like to come work for me, please have them contact me. This is one of those good problems where suddenly a fair amount of funding came in for some pretty short timeline projects, and I need more personnel.
So, Mary Beth, I'm trying to remember the project name, but Brad's work with Nicole and others in GTRI, which is trying to look at VR training for first responders.
Hmm.
And the reason I'm bringing this up is there's all this background research in what are what are the different things that they want to train people to be paying attention to. Um, so that seems like a potential application of this, which is that in training environments, perhaps you're you're trying to decrease the salience of some aspects and increase others as part of a training scenario.
Mm-hmm. Yeah, so as part of the Cisco work, I think we're gonna revisit a collaboration that we had a couple of years ago with folks at Emory in the highly infectious disease group, that dealt with the Ebola patients and others like that. Because we created an AR training environment for them, focus on spill cleanup. So, that fits these requirements that it's a task where you are having to assess the physical environment. You're having to, physically, like you're having to don PPE and clean, and you're doing the cleaning using these different tools, and you have to follow this protocol. But meanwhile, it's a very high stress environment because you are in the room with someone with this highly, dangerous disease. The person may be like very ill and delusional. And so the problem they had was it's hard to train for that because the real situation is so different from the typical training environment. And so we were using, in that case, we were using immersion to try to create an environment where you're present and feeling some of that stress that you would in the real setting. But yeah, I can see how, you could use this. Again, it's kind of cool because you could turn the dial up and down. This is another idea I've had for a long time that I've never turned into a proposal around. You'd love to have this presence dial for immersive systems for training, where it's like, okay, I could give you the full-on experience, or I can like dial it down some. I know, folks doing like phobia therapy with VR explore those ideas, but yeah, so like using these techniques to control the level of presence, but yeah, also then training some of these techniques about how do I visually inspect the scene, what do I listen for, what do I look for.
Yeah, that looked like that work you were doing with like defects, home inspections,
mm-hmm.
right?
Right. Yeah, so in some cases the like especially the enhancement choices might, like the input to that could be some knowledge of how the expert does the task. Like there's some past AR work where they were teaching people how to inspect an airplane fuselage, and so they used an eye tracker to see how experts looked at the space, and then they visualize that for trainees to try to guide them in how they look around. It's kind of like what Russ was saying. So you can imagine this recorded data that is part of the input to the system.
I was wondering, should we create like IPaT escape rooms, but you wear different like lenses on you to whether we practice whether it draws your attention to where the clues are?
Yeah. Yeah, it's like the cheat mode. You could turn on the scaffolding.
Exactly. And how much does the cheating help you? And then we could publish that.
Mm-hmm. That kind of makes me think about some of the mechanics that you see in video games, where,
mm-hmm.
It can, like, you might have it in a mode where it visually highlights the loot to make, but if you're in the hard mode, that's turned off, so you really you have to do more searching, or where it's using audio, like it's indicating to you your health level by filtering the ambient audio more, so it's sounding more muffled. Yeah. So there's probably some interesting things to learn from those particular techniques, like the visual techniques and the audio techniques they've used.
Like in the Lego game, if something could be built, right, that had a little like sparkle or some sort of quality to it, like if you passed over it,
mm-hmm.
It's like, oh, you can do something with this.
Yeah.
I miss those days.
I remember watching Little Buzz play Lego Star Wars when he was like 3 years
A lot.
old.
I know.
It was so funny. He was so good at it. And he was like standing up with the little Wii controllers.
Yeah.
So in games, another thing that I see sometimes is like the ability to scan certain items in the environment to like get more visual like text about how to use it, what to do with it, or just like otherwise background like context info. That might be a point of inspiration.
Mm-hmm, mm-hmm. Using gaze and dwell to like kind of you could almost maybe like turn down the diminishment. Like if you indicate in some manner that like, okay, I want to see more about this. I mean, that might be an approach with this situational awareness problem, that you can choose to focus your attention, and it's going to kind of like open it back up, reveal it to you. And then if you're turning away, it like hides it again. It was fun creating the content for that classroom because we were trying to be super annoying. So we're like, when we're shooting, we're in there like typing really loudly on our keyboards and like leaning over and whispering to each other, and, like, eating chips.
Oh, it's like a faculty meeting.
See, I have the exact opposite problem. Teaching online, I need only enhancements because I have no sign of life from anyone.
So the other thing is, and again, I don't know if you said this, you're talking about how things, some sense, come into sharper focus as you attend to them, right?
Mm-hmm.
But that's also feedback for that if you're going to use voice or some other command, this is the object to whom that is going to receive that command, which is always a real challenge in these types of settings, right? You're not sure exactly, so it's the selection, it's just the selection problem.
Well, and if you're, like in my remote expert example, it could be that what matters is the gaze of the person that's there on site, right? So being able to have this enhancement on my screen that's being driven by like what you're looking at.
Mm-hmm. So you can still see the overall context, but again, that shared focus.
Mm-hmm. So cold out here on the porch.
Yeah, I was noticing you're out there. It's cold today.
This is the place where I can be undisturbed, except by the leaf blowers, the lawn crews that never fail to show up right when I'm giving a talk.
The question, just a comment. Great presentation, Maribeth. This is Erin.
Well, thank you. Yeah, so Russ, we should talk more about, I'd love to get some more like real world scenarios from you about the barriers y'all are encountering with these IoT installs.
Yeah, that'd be fun. We should definitely do that. I need to make a trip to Gilbert Street soon.
Oh, yeah. Have you had your second shot?
I have.
Ooh.
Anything else from Maribeth? Very quiet. thank you. We
Well, thank y'all
appreciate
for
you
coming.
giving us some of your time today.
Well, it was nice to have. This is the kind of interaction I haven't had in a year. Like just kind of being able to share and chat with everyone about projects that we're doing.
Yeah, we need to get Walter to write us the space stuff. You know, Georgia Tech is very keen with all of our work that's related to NASA.
Mm.
Yeah, well, it'd be good context for today's Daily Digest story, right? About the new space station director or the
Yep.